So in this video, I'm going to be working through worksheet 8.1. So if you haven't done this yet, I would recommend you print it off from the Canvas page, worksheet 8.1, and either do it first and then watch the video, or kind of do a couple and check the video, do a couple and check the video. Okay, so I already did one of them here, just filled it in, so you can, if you've already done the first one, you could check that and see if your answer is right. The reason why it's not a function is because notice that 1 is connected to -2, but then later 1 is connected to 3. So remember, what makes something a function is if every input is connected to only one output. And so in this case, 1 is connected to -2 and 3. Okay, here we go. Number 2 is a function. Is it a function? So I'm just looking to see if every input has exactly one output, and notice there's only, 1 goes to 1, 2 goes to 2, 3 goes to 5, 4 goes to 10, 5 goes to 15. So there isn't any input connected with two different outputs. So this is, yes, it is a function. The domain, I'm just going to list them. So once again, I'm going to use these braces. So that'd be 1, 2, 3, 4, 5. Close the braces. And the range is just the output values, or the y values. So that would be 1, 2, 5, 10, 15. Okay. Same idea on here. The function, I have a 17 and got 17 is connected there, and it's not connected anywhere else. And 15 is connected there and nowhere else, etc. So it looks like it is a function. And my domain is going to be 17, 15 fourths, 15, and 17 fourths. And my range will be 15 fourths, 17, 17 fourths, and 15. Okay, here we go. This is not going to be a function because notice -3 is attached to 2/5 and -3 is attached to 3/5. That makes it not a function. I still can talk about the domain of this thing. The domain would be -3, 3/2, and 5. And the range would be 2/5, 3/5, -5, and I don't write 2/5 again. Okay. Moving right along, number 5, when it says relation, you're supposed to describe which ones go together. So I'm going to write the domain first. The domain is -2 because of that point, and -1 because of that point, and 1 because of those 2 points, and 3 because of those 2 points. And then the range is going to be -2 because of these 2 points, and 0 because of that point right there, and 1 because of those 2 points, and then 3 because of that point. Is it a function? No, because this x value of 1, is connected to a y value of 0 and a y value of 1. So it's not a function. Now the relation part, what we need to do is just describe how they're related, or who's related to who, so to speak. So we know that -2 is related to -2, and we know that -1 is related to, -1 is related to +1, and 1 is related to 0 and +1, and 3 is related to 3 and -2. So that would be one way to show how they're related. So I'm answering this question right here. You could just give ordered pairs. That would be another way to show it, like I did over here. So notice I just listed all the ordered pairs. So that tells me that -2 goes to 3, 0 goes to 1, etc. And then I list the domain and the range, and it is a function. Okay? So here's another example. Looks like what's related is -2 goes with 0, and 1, negative 1 goes with 2, and 1 goes with 2, that point right there, and finally 2 goes with 0. And so the domain would be negative 2, negative 1, 1, and 2. The range would be just 0 and 2. And this is a function because negative 2 is only connected with 0 and nothing else. Negative 1 is connected with 2 and nothing else. 1 is connected with 2 and nothing else. And 2 is connected with 0 and nothing else. Another way to do a quick check when you look in the graph is notice that there's no dots that are above or below each other. Right? There's nothing in line with this guy here, nothing in line with this guy, nothing in line with that guy, and nothing in line with that guy. So this is a function. This is not a function, and you can tell right away because of those guys right there. Right? One's on top of the other. So the relation here is going to be negative 2, comma, negative 2, and negative 2, comma, negative 4. And again, that's what tells me it's not a function. And then also negative 1 and 1, and 1 and negative 2, and 3 and 0. So then the domain would be, do the squigglies, that'd be negative 2, negative 1, 1, and 3. And the range would be negative 4, negative 2, 1, I already did negative 2, and 0, so I'll put a 0 there and a 1 there. Okay? Just trying to get them in order. And, of course, we can keep going like this. And this says expresses a mapping, which means is kind of like the way I did up there. So this would be, if I wanted to express this as a mapping, I would say the domain is negative 2, 0, and 5, and the range is negative 1, 3, 4, and negative 2 goes to negative 1, 0, negative 2 goes to negative 1 and 3, 0 goes to only 3, and 5 goes to 4. And so the domain is negative 2, 0, and 5. Whoops. And the range is negative 1, 3, and 4. And it is not a function because negative 2 is connected to two different outputs. Okay, I'm going to finish these two up offline and then turn. Okay, there's 8, 9, 10, 11, and 12 done. So you can take a look at those and see if they make sense to you. We had 2 non-functions and 2 functions. This number 12 sometimes troubles people because it is a function. Notice every input only has one output. In fact, there's only one output available, so an input couldn't have a second output. All the inputs go to that same output, and that's still a function. Okay? All right, so then we cruise down here, and these are a little bit different because they actually have an infinite number of items in the domain range. So instead of listing them, we have to write them in interval notation. And so basically what you're doing is finding out what is for the domain, what's the leftmost number we use and what's the rightmost number we use. So this point right here is the furthest to the left, and its x-coordinate is negative 5. So I'm going to say it starts at negative 5, and it goes all the way to that point right there. Again, in terms of x, that would be 7. So this means the interval from negative 5 to 7, including negative 5 and 7. And the range is going to be similar. We look at the lowest value, which looks like negative 9, and that goes all the way up here to positive 9. And this is a function because there isn't any overlap vertically. Okay, and here's another one we just did. The domain is from negative infinity to infinity because notice these arrows are going forever up and to the left. And this number is going forever up and to the right. So that means it's going to get as wide as we need it to. So all x values are going to be found in this graph somewhere as an x-coordinate. But notice the lowest it goes, as far as the y's go, is 2 is the lowest y value you'll ever get out of this function. Okay, and here's another one. This is a function, and again, it's all real numbers, or from negative infinity to positive infinity, because these arrows go forever to the left and forever to the right. But as far as the range is concerned, the lowest number is -5. And notice we put a square bracket there. Okay, over here, the domain, again, these arrows mean it keeps going to the left and right. So the domain is going to be all real numbers, or from negative infinity to infinity, if we put it in interval notation. The range, notice the smallest it ever gets is -1, right there. You can see that it's between here and there. So the smallest it gets is 1, and the biggest it gets is, the smallest it gets is -1, and the biggest it gets is +1. And notice we put square brackets because it does hit -1 and it does hit +1. And yes, this is a function. Over here, the leftmost thing, the leftmost point has a x-coordinate of -8. So -8 is at the left end of my domain. And the rightmost point is right here. Its x-coordinate is 2. So that would be my domain. And the lowest y-coordinate is -5. And the highest y-coordinate is, looks like 8. And again, this is a function. It's just a straight line. This is a function because there is no vertical overlap. And then the domain looks like it starts at 0. That's the lowest, farthest it goes to the left, and ends here at 6. And everything in between works. Then on the bottom, or the range, it's kind of hard to tell, but that looks like maybe about -8. So I'm just estimating here because I don't know for sure. And it goes up definitely above 18, so I'm saying it goes maybe to 19. And so that would be my range. Got a couple more here. This is not a domain. I'm sorry, not a function. Because notice that this x value right here is connected to that y value and that y value. So it's not a function. The domain, the furthest over it goes to the left is -2. And it goes forever on the other side. And the range looks like it goes from ever to forever, because these arrows mean forever up and down. This one is a function, yes. And it goes from negative infinity to infinity, and from negative infinity to infinity. This one here, the domain goes from negative infinity to infinity, because you can see those arrows saying it just keeps going, right? The range, as I'm looking up and down, looks like the lowest value is -1, and the highest value is +1. And those are included because it actually hits there. And this is a domain. I'm sorry, is a function. I keep saying that. Okay, this is not a function because you can see all kinds of x's that have more than one output. So we'd say no here. And the domain starts at -1, it looks like, and goes to, is that right? No, I'm sorry, it starts at -2. You're all saying, what is he talking about? And goes to +2. And the range is the same. It starts at -2, goes up to +2. Okay, here's a nice, this is absolute value function. We'll talk about those later in class. But it is a function. The domain looks like all real numbers, so I go from negative infinity to infinity. And the range looks like it starts at -1 and goes forever. This is still not a function. It's like that one, only it's just half of it. The domain is going to go from 0 to 2, and the range will go from -2 to 2. Looks like we got one more here. That is not a function because there's a bunch of x values that have 3 y values, right? And so that is not. And the domain would be all real numbers because it goes forever in both directions. And the range, it looks like the lowest it gets is -1. And the highest it gets is +1. Now this, without looking at it closer and knowing what's going on, if it actually does hit there and just stays flat, then this would be correct. But there is functions that could look like this, where there's an asymptote here, where the graph gets forever close to it and never reaches it. So in that case, if that's what's happening, I can't tell by looking at this, but if that's what's happening, we would put -1, 1, because we're saying that it won't go below -1, but it won't actually reach -1. This looks like it's actually hitting it and sitting right on it, but I just wanted to make that comment while we're here on this one. Okay, that's the end of that. Let me know if you have any questions.